Hi everybody, welcome back to Chapter 5. Starting on page 242 of your textbook, we will begin the study of present values. The book goes through some really cool math, and if you're into that sort of stuff, I'll let you review the math, but this lecture will emphasize finding present values by using Table 2, shown at the back of your textbook. Table 2, it's the second page of the present value tables. So let's use Table 2 to solve this problem. The present value of $1,331 received at the end of 3 years when the interest rate is 10%. The interest I is 10%, N equals 3 years, and what we want to know is what is the present value of $1,331. This is an excerpt from that table, looking down the column for periods of time, N equals 3, and then looking across the interest columns, we come to the 10% column, and at that intersection we have a factor of 0.75131. If we multiply that factor times $1,331, we will calculate a present value of $1,000. This present value calculation could be used to answer the question, how much would I need to put into a savings account today when the account pays 10% interest compounded annually if I want to have a little over $1,300 at the end of 3 years? Another question these days might be, where on earth can I find a savings account that pays 3% interest, much less 10% interest? I'm going to let you read the textbook about why you should choose one present value over another and go directly to slide 14. You probably figured out that there is a relationship between the present value and the future value. The process of computing future value adds interest to a known present value. In the previous examples, we added $331 of interest to the present value of $1,000 to arrive at a future value of $1,331. The process of computing the present value removes the compound interest from a known future value. In the previous examples in the previous video lecture, we removed $331 of interest earned over the 3-year period from the future value of $1,331 to calculate a present value of $1,000. Here's another problem for you to work. Please pause this video to answer the following question. The Versatile Company purchased a delivery truck on February 1st, 2021. The agreement required Versatile to pay the purchase price of $44,000 on February 1st, 2022, a year later. Assuming an 8% interest rate to calculate the price of the truck, Versatile would multiply the $44,000 future value by a factor found on which table to calculate the present value of that truck? And if you chose answer B, Table 2, present value, you're absolutely right. As explained on the bottom of page 243 in your textbook, we can use the present value and future value tables to solve for unknown values. As explained in the text, there are 4 variables in the process of adjusting a single cash flow amount for the time value of money. First variable is the present value, frequently referred to as PV. Next, the future value, frequently referred to as FV. The number of compounding periods, referred to as N, and the interest rate, referred to as I. If you know any 3 of those, the 4th can be calculated. Suppose a friend asks to borrow $500 today and promises to repay you $605 2 years from now. What is the annual interest rate you would be agreeing to? The present value is $500. The future value is $605. N equals 2 years. But what we don't know is the interest rate. We can solve for the interest rate in 2 easy steps. First, divide the present value by the future value to calculate a factor. $500 divided by $605 equals 0.82645. Then turn to Table 2 of the at the back of the textbook and read row 2, because n equals 2, across until you see that factor or something close to it. So reading across, I'm looking for 0.82645. 0.82645. It is 10% column. That means that the interest rate for this problem is 10%. The effective interest rate is 10%. Another problem. Suppose you want to invest $10,000 today to accumulate $16,000 for graduate school. If you can invest at an interest rate of 10% compounded annually, how many years will it take to accumulate the required amount? The present value equals $10,000. The future value equals $16,000. I equals 10%. What we don't know is how many years, the number of periods. Looking at Table 2. Before we go to Table 2, though, let me explain that we can solve for the number of years in, again, 2 easy steps. First, divide the present value by the future value to calculate a factor. $10,000 present value divided by $16,000 future value is a factor of 0.625. Then turn to Table 2. Find the column, 10% column, and read down till you find a factor close to 0.625. 0.625, it's right about here. It's not exact, but it's close. And you read that over to the left till you come to n equals 5. So it will take approximately 5 years to accumulate the extra $6,000, making your balance in the account grow from $10,000 to $16,000. Accountants use present value calculations a lot. Pages 246 and 247 give you some idea of the types of present value calculations we will be doing in future chapters of this textbook. Well, that's it for this presentation. But before you turn the lights off on your study for the day, I strongly suggest that you work the concept review exercise on page 246 of your textbook. The solutions are given directly after the problem so you can have immediate feedback on how well you understand the present value and future value calculations presented in Part A of Chapter 5.